All right, in section 4.3, we already have, you guys have your paper out? Okay, go ahead and label up your notes. 4.3, graphing proportional relationships. Can somebody tell me what it means for numbers to be proportional? Anything? Just kind of give me your thoughts on it, Sherelle. Okay, so basically it could be multiplied or divided by the same number. Okay, could we say that? So basically there's the same operation or the same number that would connect them. All right, so we say that ratios or values are proportional when the same number connects them. And that's what we're going to see today in our lesson. So go ahead and set it up. The term graphing is a little deceiving because we're actually not doing a ton of graphing today. Really, you're going to see a pretty strong connection into section 4.1 between what we're doing today and what we've already covered in section 4.1. All right, so some important information we need to know, okay? This whole equation, y equals mx, is really the backbone to today's lesson, meaning it is the most important piece that holds all the other concepts together. We have to understand y equals mx and what's happening between my variables, okay? So I'm going to try to explain it best I can, but I want you to go ahead and write down just the statement we have here, the three ordered pairs, and your equation y equals mx. Okay, so let's look at the equation y equals mx. All right, so everybody look up here on the screen for a minute. Okay, so m represents my rate of change, okay? Basically, it's the missing piece that tells me what I'm doing to x to get to y, all right? So let me just give you a sample equation. If I said y equals 5x, what am I doing to my x value to get to my y? I'm multiplying by 5. So if I were to have an x value of 2, what would my y value be? 10, okay? So the m value tells me what I'm doing to x to get to y. All right, it's what I call my rate of change, okay? So that's what I'm trying to figure out. I'm going to be given ordered pairs or even points on a graph, and I need to figure out what that rate of change is. What value is basically being multiplied or divided by x to get to my y. All right, so let's look at these three ordered pairs. How could I get, let's start at the first one. How could I get from a 3 to a 6? How could I get from a 3 to a 6? Multiply by what? Multiply by 2. So I'm suspecting that I have an m value of 2, okay? Because I'm going to multiply by 2 here. All right, but I have to test it with all of the ordered pairs because it has to be the same rate of change for all of the sets of numbers. If it's different on even one of them, then the relationship is not proportional. All right, and that's what I'm trying to get to. Is the relationship in this linear equation or in this set of ordered pairs proportional? Is it or not? All right, so is it true that 4 times 2 is 8? Okay, so that's correct. And is it true that 5 times 2 is 10? Yes, that's correct. So because I could verify that I'm doing the same operation to all three of these ordered pairs, I can now conclude that the equation y equals, what did I do to x? Multiplied by 2 is the equation that would represent these ordered pairs. All right, so I'm working basically backwards from what you've done in 4.1, in section 4.1. Now I'm coming up with the equation that is represented by the ordered pairs, but I can only do that if it's a proportional relationship, meaning I'm doing the same thing to all the ordered pairs. All right? Okay, so y equals mx is really important. Okay, m stands for my rate of change. Got it? Let's look at example 1. So in example 1, it goes ahead and tells me this is a proportional relationship. What am I doing to each x value according to the equation? I'm multiplying by 4. So that's the proportional relationship. Well, we've already graphed equations. Actually, everything that we do in this example, you've already done in section 4.1. It's just now I'm calling it a proportional relationship. Okay? I'm saying that each x value, the same thing is happening to y. Okay? So let's set it up. Now, because it's connected to a whole number, what's my standard set of values that I want to use? What's my standard set of values? There's three numbers. -2, 0, and 2. Okay? I just want to use that same standard set every time. -2, 0, and 2. Go ahead and make your substitutions and come up with your y values. What did you get when you did 4 times -2? -8. What's 4 times 0? And what's 4 times 2? 8. Who got the table correct? Who got the table correct? Raise your hand. Okay, so now you don't necessarily have to graph this, okay? This is something you'll be given a graph on your quiz. But I just want you to kind of look up here and visualize where we're going to plot these points. Left 2, down 8, 0, 0, and 2, 8. Okay? If I did not have any of this, the table, the equation, anything, I actually can know that it's proportional, because here's what will be true about every single graph that is proportional. It will pass through point 0, 0 in what we call the origin. If it passes through the origin, I know that it's a proportional relationship. Okay, so I know that we kind of just basically covered two concepts within one example, but I need you to understand that if you did not have the equation given to you, and this is actually 2 problems on your homework, and we're about to talk about this again in just a second, but if you didn't have the equation, you can tell just by the graph that it's proportional, okay? Does that make sense? And how do you know that it's proportional? What did I just say? It has to pass through the origin, okay? So I know it's proportional because the problem told me, but even if it didn't, the graph tells me also. All right, and it's confirmation that I graphed it right, okay? So that's important too. All right, next example. Does the graph represent a proportional relationship? All right, so I'm going to give you 3 lines, okay? Again, this isn't necessarily something you have to graph yourselves. You just need to watch the screen, and we're looking for that indicator that we just talked about to tell us which line actually represents the proportional relationship. Okay, so we've got this one right here. All right, so here's my 3 lines, okay? Lines A, B, and C. On your notes, I want you to tell me which one of these represents a proportional relationship. I'm not saying that it's not a linear equation. I mean, obviously it is, but is it a proportional relationship? Well, that's a different story, okay? So you write down A, B, or C, and you have to tell why. So on your homework, this is numbers 10 and 11 on your homework. It's important that you understand the why, because without the why, you're not going to get full credit. All right, so who can tell me, is it A, B, or C? Just tell me.
B.
It's B, and what's the why?
Because it passes through the origin.
B is yes, proportional, because it passes through origin, okay? All right, so that's what you're going to write. It passes through origin. All right, so on the flip side, A and C are a no because it does not pass through the origin. That really is the indicator, okay? It does not pass through origin. All right, we can abbreviate. I know that's not typically how we spell through, okay, or because. All right, so it's really just all about the origin, the point of origin. All right, next example, really important. You have 2 problems like this on your homework, and you definitely can expect this on your quiz and test, okay? Where I give you a set of values, of x, y values, and you have to tell me, do these values form a proportional relationship? And if so, what would be the equation? So the equation, guys, is y equals mx. All right, that's still my basis. But is the rate of change the same value between all of the sets of ordered pairs? It has to be the same number. If it's different, then your answer is no, that the ordered pairs are not proportional. Okay? So what we're looking for is from x to y, not y to x, but from x to y, can I do the same operation to get to my y value? All right, so I want you to look at the first table. If your answer is yes, what is that operation and value? And then put it into an equation. Okay, so what am I doing to 10 to get to 2? What am I doing? Dividing by 5. So now I need to test that pattern and make sure that all of the others match. 15 divided by 3. I'm sorry, 15 divided by 5 is 3, so I can divide by 5. 20 divided by 5 is 4. And 30 divided by 5 is 6. So that works, okay? So what am I doing to my x? I am dividing by 5. 1/5 times x. Basically, I'm taking a fifth of x. You could write it y equals x, my x value divided by 5. I would take that too, okay? But you have to show division because that's what you're doing to x. You're dividing by a value, okay? So go ahead and answer the second one now. If it's yes, give the equation. If it's no, you need to tell me which ordered pair breaks the sequence. Okay? So that's your explain. That's your reasoning. Okay? If it's yes, give me the equation. If it's no, tell me which ordered pair breaks the sequence. Okay, so how do I get from 8 to 2? How do I get from 8 to 2, guys? Divide by 4. So my suspicion is that it's y equals 1/4 x. But I need to test that. 12 divided by what gives me 4? 3. So because I'm dividing by a different number, it doesn't necessarily mean it's not linear, but it is not proportional. 16 divided by 4 is 4. 24 divided by 4 is 6. But this set is what breaks my sequence. So I would say no. And my reason is ordered pair 12, 4 is not proportional. Not proportional. Okay, so that's my reason to the other sets. All right, any questions on reading the table? 2 questions like that on your homework. All right, the last one, you need to turn to page 157 in your books. Example 4, page 157 in your books. We're going to read it together, and then we need to set up, again, y equals mx is our starting point, okay? So again, I told you at the beginning of the lesson, and it's very true, this is the backbone of the lesson. This is what holds all of the examples and all the concepts together, is this equation that we keep looking at where we have our x and y value, and there's some operation that connects them, okay? And that's what we have to figure out. So page 157 in your textbooks. Everybody should be open to that page. Okay, so it says the weight. What letter comes after the word weight? Elizabeth, sit up, please. The weight what? The weight y. Okay, so these problems are going to tell you which value is which. The weight y of an object on Titan, which is one of Saturn's moons, is proportional to the weight x of the object on Earth. An object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. Okay, so it's important that we know which value is represented by which variable. It said that y stood for what? The weight on which surface? Titan. Okay? So we're creating here what we call a verbal model. We don't know how they're related. That's our m. That's our rate of change. We don't know how they're related yet, but we know that x is our value on Earth. Okay? So now we're going to plug in values. 105 was which value? Earth or Titan? Earth. So that's why I plug in 105 for Earth. Okay, times m. All right, equals, what is the weight on Titan? If it's 105 on Earth, what's the weight on Titan? 15, okay? This is all information the problem gives us, okay? So if I know that it's 105 pounds on Earth and 15 on Titan, I can figure out what's happening, how many I'm clearly dividing because it's lower. All right, what value I'm dividing by, and I can do that by solving an equation. Is there a better way that I could write a number times a variable? How am I supposed to write that algebraically? 105m, okay? So let's go ahead and make sure we write that algebraically. And again, multiplication order doesn't matter. I can write it 105m. And don't be thrown off by the fact that 105 is the larger number. It's still what's connected to m, okay? So I divide both sides by 105 because I have to solve for m. And now I need to reduce this fraction. 15 over 105 reduces to what? 1/7. So what does that mean about what's happening to the weight between Earth and Titan? What's happening to the weight? That's my rate of change. What is happening to the weight between Earth and Titan? Am I multiplying it? Dividing by what value? 7. Okay? So let's plug in some random numbers, okay? What if something weighed 49 pounds on Earth? How much is it going to weigh on Titan? It's 1/7, so I divide by 7, so how much does it weigh on Titan? 7 pounds. Okay? Now let's go in reverse. What if it weighs 10 pounds on Titan? How much is it going to weigh on Earth? 70 pounds. Okay? Because 7, guys, that rate of change tells me how it's converting. All right, let's do another one. What if it was 35 pounds on Earth? How much is it going to weigh on Titan? 5. Very good. Now let's do one more. We're all going to get this one right. What if it weighs 3 pounds on Titan? How much will it weigh on Earth? 21. Okay, so you see how it's related now. This rate of change tells me how they relate back and forth. All right, so now letter B says, how much would a chunk of ice that weighs 3.5 pounds on Titan weigh on Earth? Okay, so the 3.5 pounds on Titan, I substitute in for Y. That's the Titan value. Equals, okay, some value on Earth. Oh, I'm sorry, that should have been an X, not an M. 1/7 was M. 1/7 times X. Okay, well, how could I solve for X? How do I solve for X? What do I do?
You do the same thing. 3.5 times
Yeah.
1/7.
Very good, times 7, okay? Because I have to get this to cancel, so I multiply the other side times 7. What's 7 times 3.5?
22.
Not 22, but 24.5 pounds on Earth, okay? And isn't that what we said? Well, I'll say X, but that's Earth, okay? Pounds on Earth. Isn't that what we said? Is if it weighs a certain amount on Titan, I can multiply it by 7 to find the weight on Earth? Well, that's what I just did, but I showed it in an equation. All right, this might be the one that you go back and watch as you're doing number 14, okay? But if you understand that, that's everything you need to know for section 4.3.